All right, hello everyone. In this video, we are going to go through some of the vector addition. We're going to look at problem 5 and problem 6 in the same video. All right, to speed things up a little bit, I drew my picture for number 5. So number 5, we're kind of playing musical chairs, but we have a chair here at the origin, and we have two people pulling on the chair at the same time. So someone's pulling with 600 newtons this way, and someone's pulling 200 newtons this way. When you use the parallelogram method, it is like super important that you draw your pictures roughly to scale. So I made sure that my 600 line was mega longer than my 200 line. So where's the chair going to end up going? Right, obviously in this path, and then I'm going to label that as C. All right, so I'm going to use cosine law to find C. And I have everything written down here, but I don't know angle C. So I have to pick a triangle to focus on. I can either pick the bottom triangle or the top triangle. I always recommend that you pick a triangle that does not have an axis going through it. So I don't like the bottom triangle. So we are going to focus our attention just on the top triangle. So if this is the top triangle, there's side C, here's one side, and this one is going to be 200. It really doesn't matter what you call A and B, but I do need to isolate angle C. So that is opposite. So this is angle C. That's opposite side C. So I got to figure out what that is. So I can't figure that out by looking up here. I have to draw my attention down here because that's where I know some things. So I do know that the corners, adjacent corners of a parallelogram add up to 180. So if I could figure out this purple line to this purple line, then this would be the complement of that. So I guess not complement, 180 minus that. All right, so if this is 30 degrees, so if I went from this purple 600 down to the x-axis, this would be 60 degrees. I'll write it kind of over here. So if this purple line to the x-axis is 60, and this is 70, so 60 plus 70, so purple to purple, I'll do it like this, purple to purple would be 130 degrees, 60 degrees plus 70 degrees. And this corner plus this corner have to add up to 180. So I now know that this has to be 50 degrees. So now I'm going to number crunch. And when you number crunch and then use square root, if for some reason you don't get the right answer, it is highly likely that you are in radians. So double check that. But I number crunched without you, and I got 495.17 newtons. So that is the net force that is being pulled on that chair. But I'm not done yet, because I also have to tell someone where the chair goes. I got to make it super clear that the chair is going at this particular path here. So I have to find an angle. And again, here's my triangle. So I think the angle that would be helpful to talk about, we already know angle C, would be the angle down here. So I'm going to call this little angle theta. So I'm trying to find this little angle theta. So I'm going to call him sine theta. And what goes on top is the side that's opposite him. So there's 200. And I'm going to set that equal to C over sine C, because I know that stuff. So side C, let's slide this up a little bit. Side C is 495.17. And this is sine of 50. And then to find theta, I like to cross multiply. I'll take a moment and write that out for you. So I get 200 sine 50, and then I'll set that equal to this, 495.17 sine theta. And just because somebody asked me today, I'm going to finish this out and talk through the algebra. I'm going to divide both sides by 495.17. That would equal sine theta. So then sine theta would equal some decimal. Let's get that decimal on my screen. So I'm going to go 200 sine 50. So let's see if it shows. So 200 times sine 50. Then I'm going to divide by 495.17. And so there's that decimal on my screen. So to get theta, I got to take the arc sine of both sides, which turns out to be second sine of the answer. So it's kind of like take the arc sine of that 0.309 blah blah button. So second sine, second answer. And somebody asked me where the answer was. So it's right down here. It's on this negative sign, but it's up on top. So I have to hit second answer in order for that to come up. So in order to get theta, second sine, second answer equals, there's my theta, 18.02. So I'm going to write that down. So theta equals 18.02. But that's not the answer. That's just this little angle here, 18.02. I'll just write 18. So I need to tell somebody where the chair is going to go. So I'm going to add it to this 30. So plus 30. And now I'm going to get 48.02 degrees. And I'm going to call that west of the north line. 48 degrees west of north. Somebody pointed out that that's not what I have on my paper. I have 42 north of west, and here I have west of north. But if you add these two things up, they add up to 90 degrees. So it's saying the same thing. I probably did this on my calculator and got that answer. So that's why I typed it out there. But if I worked it out on paper, I think that I would have written it this way. So it doesn't matter. They're both correct. But let's check our work now by doing the component method. So I'm now moving on to number 6. All right, so for number 6, it's not as important that I draw my picture to scale. But regardless, I'm going to get my vectors in here. So this was a 600. And this was 30 degrees. And this was 70 degrees. And this was a 200. All right, so for component method, we take our vectors and we break each of them down into their x and their y components. So I'm going to make a little component chart here. And since these are forces, I'm going to call this the x component of the force and the y component of the force. And I'll start with the 600. I will do one of them and show you the trig just as a review. So I always like to use the angle that drops to the x-axis. So instead of this 30, I'm going to use this 60. And I want to know what this x piece is and what this y piece is. So you'll notice the x piece is adjacent to the 60. So I could say that cosine of 60 would be the x piece over the hypotenuse, which is 600. The reason I like to use the angle that drops to the x-axis is because the x component then will always turn out to be 600 times cosine 60. 600 times cosine of 60. And the y component will always turn out to be sine 600 times sine of 60. But we have to put in the negatives. So this is the positive y direction, so that one's fine. But this is the negative x direction, so I'm going to throw a negative in there. All right, let's look at now the bottom vector. If I make that into a triangle, kind of like that, I already have the angle dropping to the x-axis. So this is going to turn out to be 200 times cosine of 70. And this will be 200 times sine of 70. Let me say that again. If you use the angle that goes to the x-axis, you'll always have cosines in this list and sines in this list. To me, it's just a nice, safe way to help minimize mistakes. but you have to remember to put in the negatives. And here we are in quadrant 3. So I'm in the negative x direction and the negative y direction. So we got to throw those in there. All right, so we took each of our vectors and broke it down into the x components and the y components. And the next step that we do is we add them up. So I'm going to add up all of the x components, and then I'm going to add up all of the y components. So again, make sure your calculator is in degrees and not radians. All right, so I have negative 600 cosine 60 plus a negative, so I'm just going to say minus 200 cosine 70, and I get negative 68.4. Whoops, I said that again. Negative 368.4. Negative 368.4. And then the y's, I get 600 sine of 60 minus 200 sine of 70. And I get minus 473.2 minus 473.2. All right, once we have the net x and y component, we can now graph it out. Hold on a second, I lost my pen. All right. All right, so I'm going to plot that over here. Well, I guess I'll just do it here. All right, so the net x component is negative 368. So I'm going to draw it in the negative x direction. So the negative x direction, and the value is going to be 368.4. So notice I dropped the negative sign because I drew it in the negative x direction. And this one is negative 473. So I have two negatives here. Hold on a sec. Okay, I'm sorry about that pause. I knew something was wrong because I can't have two negatives here. So I just re-number crunched, and I number crunched my y values incorrectly. So I redid it here, and this is not negative 473. That number is 331.68. 331.68. All right, let's see if we can salvage my video here. Okay, so I drew this in the negative x direction, and now I have to draw this in the positive y direction. Now I am going to parallelogram method this, which means that I do want to draw this roughly to scale. So I made sure that my 331 arrow was a little bit shorter than this arrow. And so now I'm going to do this. And this is where the chair is going to go. So I'm going to call that C. And it should be going in the same spot it did for number 5, which is how I knew I made a mistake someplace. All right, so, but this time I have a right triangle. So, whoops, I'm not going to use C squared. C equals. So I'm just going to use A squared plus B squared equals C squared, and we're going to number crunch that and get C. So I'm going to get 331.68 squared plus 368.4 squared, then we'll square root that mess. And we get 495.71. 495.71. It's looking pretty good compared to our last time, 495.71. All right, but now I got to tell somebody what angle. So I could find this angle or this angle, but since I found this angle last time, I think I'm going to find that angle again. So I'm going to use tangent. Technically, you could use sine, cosine, or tangent. It doesn't really matter. I just seem to like tangent. That would be opposite, which is going to be 368.4 over the adjacent, which is 331.68. Then I'm going to have to do inverse tan, inverse answer. So I have 368.4 divided by 331.68. Second tan, second answer, and I get 48 degrees. 48 degrees, and that is west of the north line. West of the north line. And if I did 90 minus 48, I would end up with 42 degrees north of west, which is the answer that is given on the sheet. So the good news about the parallelogram method and the component method, when you use them together in the same problem, is you can check yourself and see if your answer is correct. So I hope the video helps clarify and bring this back to your memory.